In this second unit, we'll see why the representation of the notes using numbers becomes very useful and very efficient when we start manipulating notes on a computational level. At the end, I view the concept of computation beyond what we can do with a simple computer, but as humans, composers, they all do computation at a level in which they combine notes according to their own different algorithms to produce the final product of their creativity. I mentioned already this concept of intervals. Now we can make the concept of intervals more mathematically sound because we have a representation in terms of numbers. And so basically, a musical interval is the difference in semitones between two notes. If I have, for instance, in this scale, I have the names of the notes here, but names of notes correspond to numbers. There would be the interval between the D and the E is the difference between 4 and 2, if C is 0. And so 4 minus 2 is 2. 2 are the semitones, the unit intervals between two notes that separate these two pitches. So, talking about intervals, the first operation that we can do, given any combination of notes, is what we call a transposition. A transposition is a mathematical operation that shifts a set of notes up or down by a constant interval. So mathematically, it's just the sum we need to sum a particular index, transposition index, to each note in order to create the new sequence. This is an example of code written in Python that you will find in the notebook that is associated to this module, where on one hand we have two functions. The first function is the function that, given a note name, gives me the number. So it gives me this numerical representation between 0 and 11 of any note name. And the second one is an example of transposition. And here, I remind you again of the fact that if we concern ourselves with a division of the octave between 0 and 11, and we consider every octave in our piano keyboard to be equivalent, this is a system that works modulo 12, and so a transposition is an operation that transposes notes modulo 12 in this case. So this is an example. Below is I define a particular scale here, and then I get the names for that scale from numbers to letters, and then I can do a transposition of that scale and see how the transposition changes this evolution. You will ask at this point, well, but I have 88 keys in the piano, so I can transpose not just modulo 12, but move around the keyboard towards higher notes regions or lower note regions. And indeed, there is a numerical representation for that too, that we'll be introducing later on, and this is what is called MIDI, Musical Instrument Digital Interface. That is a standard that uses a numerical system that identifies each individual keys on the keyboard from a number 20 to a number 108. But we will not be using that for now. We will be concerned mostly with the division of the octave between 0 and 11. Transposition is an operation that we do on a set of pitches. There are other operations that we can do and we can define mathematically and computationally. The next one is what we call the retrograde. That is basically taking a sequence of notes and invert their sequence. So we reverse the order of a group of notes. And here there is an example of code that does that. and the final example given a scale, how the retrograde of that scale would work. I can demonstrate this on the piano. Another operation that is fundamental in music creation is what we call a rotation. A rotation is when we take a sequence of notes, and instead of starting from the first note, we start from any successive notes, and then we wrap around to go back and complete the sequence. So let's hear an example here. This is the original. This is rotated by 2 steps. This is rotated by 1 step. This applies to melody, but more importantly, applies to the combination of more pitches. This is the time to introduce the concept of chord. In the previous examples, I always played individual pitches one at a time. But in music, we often, or almost always, play more than one pitch at a time in what we call a chord. An example of a chord is if I take these 3 pitches, and I play them together. Chords are at the basis of harmony and are going to play a very important role in all our discussions in the following modules and units, because they will allow us to quantify, in a way, the harmonic complexity of a composition. That is one of the concepts that I will introduce as one of the foundational ideas of this course. If we go back to the idea of rotation, if I look at chords and apply rotation to a chord, what I have is what is called in musical language is an inversion. So a chord inversion is a rotation where the lowest note of a chord changes according to the rotation of the pitches. And so in the example of before, this is the original chord. This is the first rotation. And this is the third rotation. These are called inversion of the same chord. Inversion has also another meaning that is related to the one I've been explaining so far, in the context of a melodic progression, so a melody where notes are separated by intervals. Inversion in this melodic context means that I take each individual intervals in the original sequence and I change them in the opposite direction. So, as in the example here in the figure, if I have intervals of 3, minus 2, plus 4, that means I go up 3, down 2, up 4. The inversion is the same interval, but with with the change sign. So I go down 3, while before I was going up 3, and then I go up 2 and down 4. We can listen to this example. In the Western musical tradition, intervals, so the difference in pitches between 2 notes, have particular names that are summarized here in this table. We don't need to really master these classifications, but it's helpful to understand how our representation in terms of integers modulo 12 translates into a musical content that is used in traditional music theory and musicology to express quality and quantity of intervals. Well, at this point it's time to put everything together. So we can take a motif that is a sequence of notes and then change it by inverting it, transposing it, retrograding it, transposing it again, and constructing from a single seed a more complex composition. Original. Inversion. Transposition. Retrograde transposition. Retrograde transposition.